Hello everyone, welcome back. In this video we are going to learn another important concept in Java multithreading, that is thread methods. We will see with a clear explanation and practical examples. Subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So imagine your Java application has multiple methods running at the same time. Now suppose you need one thread to pause for 2 seconds, or you need the main thread to wait until another thread finishes, or maybe a thread is sleeping and you want to signal that it should stop waiting. So how do we control all of this? So Java provides several important methods, thread methods, for exactly these kind of situations. So in this video, we will understand sleep, join, interrupt, isAlive, currentThread, and thread names and priorities with practical examples. And when we reach interrupt, we will clear up one of the biggest misconceptions that stopping a thread, Okay, so let's start with one of the most commonly used methods, that is sleep. Okay, so these are some of the most important methods you will encounter when working with Java threads. Instead of simply memorizing their definition, we will understand what each method actually does during thread execution. Okay, we will start with sleep, but there is one important question. When we call thread.sleep, which thread actually goes to sleep? So the sleep method temporarily pauses the execution of current thread for a specified amount of time. So it pauses the current thread for a specified amount of time. So here thread.sleep with 200 milliseconds, 2000 milliseconds asks the current executing thread to sleep for approximately 2 seconds. 2000 milliseconds means 2 seconds. Okay. While sleeping, the thread enters the timed waiting state. Timed waiting states, since we are providing the time, okay, which we discussed in the previous video. So after the sleep duration expires, the thread becomes eligible to run again. But notice something important. We are calling sleep using a thread class. See here, thread class. That is because sleep is a static method, and for a static method we can directly call with the class name, and it always affects the currently executing thread. So always remember, when we call sleep method, it pauses the current thread for specified amount of time. Okay, so I will show you one example how it works. So let's say I'm writing one for loop equals to 1 less than equals to 5. So this loop will iterate for 5 iteration, 1 to 5. Okay, and I will print value each time, and inside for loop I will write try catch block, and here I will write thread.sleep, let's say for 1000, that is 1 second. Okay, and in catch I will write interrupted exception. We'll simply write it is interrupted. Okay, so what we are doing inside this code, we are just writing a loop. So this loop will iterate 5 times. So for each iteration it will wait for 1 second, sleep for 1 second. So current thread will sleep for 1 second. Okay, so we have a loop printing numbers See in this line, numbers from 1 to 5. After printing each number, the current thread sleeps for 1 second. So instead of printing all the numbers immediately, we should see approximately a 1 second delay between them. Notice that sleep can throw interrupted exception. Why would a sleeping thread be interrupted? Keep that question in mind because we will answer it when we reach the interrupt method. Okay? So now let's verify how this program is behaving. See, it is waiting for 1 second for each iteration. See, that's how it printed 5. Okay. Now imagine we start a worker thread that performs some important task. Okay. And immediately after starting it, the main thread continues executing. Okay. So what I am saying, let's say I am creating any thread equals to new thread, and here I am providing run method. Let's say it will just simply print running. Okay, so this is one thread I have created in which I have defined the run method, what it will do, what this thread will do. Okay, now I'm calling the start method, and after calling start method I am writing main finished, main finished. Okay, so we are starting a worker thread. This is what worker thread. Okay, why we are calling worker thread? Because it is working on some task. Okay, we are calling worker thread. It is performing some important task. So here I have just written it will print running, and immediately after starting this thread, the main thread continues executing. So which one finish first? That is the question. So we cannot simply assume that the worker thread will finish before the main thread. Okay, why? Because thread scheduling can vary. Thread scheduling is done by JVM operating system, so this can vary. But what if the main thread must wait until the worker thread completes? So this is like main thread. Inside main thread we are creating another thread and calling start method. But I am saying, what if the main thread must wait until this worker thread completes? So after completion of this worker thread, only the remaining lines of code of main thread should get executed. That is exactly where join becomes useful. Okay, so now explore join method. We have seen this thing. Yeah, so the join method allows one thread to wait for another thread to terminate. Okay, think like it, like suppose you have the main thread. This is what main thread. Okay, and main thread is running, and you are calling somewhere in the main thread, let's say t1.join. So at this line execution, main thread will wait until this thread terminates or completes. So main thread will wait until it terminates or finishes, then main thread will continue its remaining lines of code. That is the use of join. So whenever we want a current thread, it can be main or any thread, right? I am giving an example of main thread. You think like current thread. So whenever you want that current thread should wait for another thread, in that case you call join on current thread. So current thread will wait until another thread terminates or finishes, then current thread will resume his job or work. Okay, so only after the worker thread or another thread finishes does the main thread continue to the next statement here. After completion of this thread, current thread or main thread will get executed. So the easiest way to remember join is wait for this thread to finish, and just like sleep, join can also throw interrupted exception. Okay, see here, main thread waiting to complete worker thread, and once worker thread is completed, main thread is continuing. Okay, now we will see a difference between sleep and join. Sleep and join. Okay, sleep and join can look similar. Why? Because both may cause the current thread to temporarily stop progressing, but their purpose is very different. Sleep means what? Sleep means wait for specified time duration. Wait for some specified time duration, specified amount of time. And join means what? Join means wait for another thread. Wait for another thread to finish. So remember this simple rule. Sleep means what? Wait for time. Wait for time. Join means what? Wait for thread to finish. Okay. So these are the difference between the sleep and join. Now we come to the method I mentioned at the beginning of the video, interrupt. Looking at the name, you might assume that calling interrupt immediately kills or forcefully stops a thread. But is that actually what happened? The answer is no. The answer is no. Calling interrupt does not simply force a thread to terminate. Okay. Instead, interruption is a cooperative signaling mechanism. Interrupt is what? Cooperative signaling. It is a cooperative signaling mechanism. Okay. We should not think like we are calling interrupt to force a thread to stop. We are stopping a thread forcefully. Okay. So let's understand what that means. What that means, cooperative signaling mechanism. So when we call interrupt, we are essentially sending an interruption request to the thread. And if the thread is blocked in certain interruptible methods, okay, so let's say we are calling interrupt method in a particular thread. And if thread is in sleep, wait, or join state, it can receive a interrupted exception. Okay. And if the thread is running normally, thread is running normally, it is not in the any of these states. In such cases, a thread's code can check that status and decide how to respond. Okay. So interruption is cooperative. That's why we say interruption is cooperative. So the thread needs to handle the interruption appropriately. That is why interrupt should not be understood as a force kill button. Okay, we should not understand it is used for killing forcefully. Okay, I will give you one example. I will remove this part, and inside the run method, what I will do, I will write one try catch block. Try catch block, and catch block I will be handling interrupted exception. Okay, interrupted exception. and I will just print thread interrupted. Okay, thread interrupted. So let's write code in the try block. So I will write sleeping, and after that I will call thread dot sleep for, let's say, 10 seconds. Okay, 10 seconds, and after that I will write woke up normally. Okay, so I have defined here the run method. Okay, I have defined run method. What it is doing, it is printing sleeping, then calling sleep. That means 10-second current thread will be in sleeping state, that is in. Okay, and after that, after 10 seconds, it will print this line. Okay, now I am starting the thread dot start, and once the thread is started, I will interrupt. Okay, so here I will give some time to start. Let's say I will give 5 seconds. Okay, 5000. So I'm giving 5 seconds to start the thread, and once thread is started, what I will do, I will interrupt that thread dot interrupt. Okay, so our worker thread tries to sleep. This is what worker thread. Okay, so worker thread, what it is trying to sleep for 10 seconds. But after starting it, we interrupt the thread. If the interruption happens while the thread is sleeping, sleep throws an interrupted exception. So it will go in the catch block and it will print thread interrupted. Okay, so this also explains why method like sleep requires us to handle interrupted exception. Okay, a sleeping thread can be interrupted. Let's verify it. I will run this program. See, it is sleeping for 10 seconds. Now we will interrupt. See, after 5 seconds we interrupted. It goes to interrupted exception and thread interrupted. See, it is printed thread interrupted. That means a sleeping thread can be interrupted. Okay. Sometimes we need to know whether a thread has started and is still alive. Okay, so for this we can use the isAlive method. isAlive method. It returns true if the thread has been started and has not yet terminated. Okay. Otherwise it will return false. So if thread is started but not terminated, it will return true or else false. So let's see something interesting by checking isAlive at 3 different moments. Okay. So what I will do, for now I will remove this part and I will simply write one statement working. Okay. So whenever we call this thread, we start this thread, the run method will call working. Okay. So I will check now. We have not called the start method. Before calling start, I will write thread.isAlive. Okay. isAlive method will return boolean value. Okay. I'm just printing it. And let's say thread dot start. I'm starting, and after starting, again I will check the isAlive status. Okay. And after that I will call join method. What join method do? Join method will wait for another thread to complete successfully. So we are calling join method from main thread. So current thread is what? Main thread. Okay, and another thread is what? This thread. This worker thread is another thread. So main thread will wait for this thread, worker thread, to finish at this line number 20. Okay, this is join method. And after join method, I am again checking the isLive method. Okay, so 3 different points we are trying to check. One is before start, another is after start, and after join. Okay, so try to predict these 3 results before we execute the program. Okay, so before start, is the thread alive? After start, what happens? And after join returns, meaning the thread has completed, what will isAlive return. Okay, so let's run it. See, so before start, is the thread alive? So before start, it is returning false. Okay, why? Because we have not called the start method, it is not alive. And after start, after the thread has been started and it has not terminated yet, it is returning true. Okay, and after the thread has terminated, it is returning false. And we are calling 20 in the line number 20, we are calling join. That means it is saying that main thread is waiting, that is current thread main thread is waiting for the worker thread to finish at this line number 20. So at line number 20, this thread is terminated after completing. How? It executed run method working. So working is printed. So at line number 20, this worker thread is finished. And after finished, I am again checking isAlive. That's why it is returning false. Okay. So one detail to remember is that a very short running thread may finish before we manage to check it. So timing can affect what we observe immediately after start. Okay. Now we will see another method. Okay. So now we have current thread. Okay. So current thread, thread.currentThread returns a reference to the thread that is currently executing that piece of code. Okay, so here we are calling thread.currentThread. It will return the currently executing thread. Okay. So for example, if we call it inside the main method, we will normally get the main thread. See, if you're calling inside this line, inside main method, this will return what? This will return main thread. Why? Because main thread is calling this method. This method is being called in the main thread. And if we call it inside the run method of another thread, then we get the worker thread. As simple as that. Okay. Why worker thread? Because we will call worker thread and worker thread will call run method as part of its thread. Okay. So if we are calling this thread.currentThread inside run method, then we will get the worker thread. So this becomes very useful when debugging multi-threaded application. Why? Because we can identify exactly which thread is executing a particular section of code. So debugging becomes very easier. Okay. Now we will see. Okay, so by default, Java assigns name such as thread 0, thread 1. We have seen in the previous example, if you are not providing the names of thread explicitly, then Java will assign the thread name like this, thread 0, okay, thread 1, and so on. But in real applications, meaningful thread names can make debugging easier. So we can use the method setName. to assign a custom thread name, okay, custom thread name, and get name to retrieve the thread name. It is very straightforward. Okay, so instead of getting this thread 0, thread 1, we can provide custom name and we can get it. Okay, so when we look at logs or debug our applications, we can immediately understand, okay, that this thread is responsible for these lines of code. So we should always provide the meaningful names to the thread. Okay, now every Java thread also has a priority. So thread priorities range from 1 to 10. 1 to 10. So minimum priority is 1, normal priority is 5, and maximum priority is 10. Okay, so we can use setPriority method to change a thread's priority, and getPriority method to retrieve the priority of the thread. But there is very important rule here. A higher priority thread is not guaranteed to execute first, okay, or finish before a lower priority thread. So let's say if we are giving some thread priority like 10 and we are giving some thread priority like 2. So it is not guaranteed that this thread will execute first before this one. There is no guarantee. Why? Why there is no guarantee? Because of thread scheduling. Okay, thread scheduling depends on what? Depends on JVM and the underlying OS, operating systems. So they decide like which thread should get priority. Okay, so you can think like priority is like a hint, scheduling hint, not as a guarantee of execution order. Okay, now here is a common interview question. Suppose thread A has priority 10 and thread B has priority 1. Will thread A always execute first? This is the question. So the answer is no. Okay, why? So you should never rely on thread priority to guarantee execution order. The thread scheduler ultimately decides which runnable threads get CPU time. So if your application requires a specific execution order, thread priority is not the correct mechanism for guaranteeing it. Okay. Now let's quickly recap what we have learned so far. So sleep temporarily pauses the current thread. Okay. Join allows the current thread to wait for another thread to finish. And interrupt sends an interruption request rather than simply forcefully killing a thread. Okay, it is a request interruption. And isAlive tells us whether a thread has been started and has not yet been terminated. Okay, and current thread gives us the currently executing thread. And thread names, okay, thread names help us to identify threads, which thread it is. Okay, and thread priority provides a scheduling hint but does not provide guarantee of execution order. If you understand what each method does to thread execution, you won't need to simply memorize these definitions. Okay, now we know how to create threads, understand their life cycle, and control their behavior using important thread methods. But multiple threads introduce a much more dangerous problem. So imagine two threads reading and modifying the exact same variable. Okay, almost the same time. So you think like we have two threads, T1 and T2, and we have the one variable, let's say X. This is variable. Okay. And both threads reading and modifying the exact same variable X at the same time. Then you might expect a simple calculation to produce one result. But run the same program again, you could get a completely different result. Okay, why does this happen? And how do we prevent multiple threads from corrupting the shared data? This is like shared data. Okay, so how can we prevent multiple threads from corrupting this shared data? That's where race conditions and synchronization becomes essential. We will understand exactly how that problem occurs in the upcoming videos. Okay, so that's all for this video. I hope you now have a clear understanding of thread methods in Java. Thanks for watching, and I will see you in the next video.